Okay, this question is about sodium and some of its compounds. Use your knowledge of structure and bonding, so I need to state the structure and bonding of everything that's in here, to explain why sodium bromide has a melting point that is higher than that of sodium and that of sodium iodide. Okay, so it's a pretty open-ended question. There's 6 marks here, which means it's going to be a levelled response, which means there's 3 stages worth 2 marks each. Best way to tackle these questions really is to do it in a table and then compare them at the end. So let's have sodium bromide over here, and then we'll have sodium iodide over here, and that's just because they're both ionic. And then we'll have sodium over here. What we'll do is I can always extend the table further, but we'll see how we get on with this. So first thing I'm going to talk about then is the structure and bonding. So structure and bonding for sodium bromide and sodium iodide, they are both giant ionic. And sodium, that's just a metal on the periodic table, so that's going to be giant metallic. Okay, next thing, I need to explain the forces of attraction before then comparing the strengths of them. Okay, so I'm going to just go through each of these. So for sodium bromide, so they're both giant ionic, so I'm kind of going to do these two together. So we have electrostatic, you don't need to write that word, but forces of attraction. Between oppositely charged ions. Okay, so that's for both of those, and we'll do a comparison between those two in a little while. And then sodium, because that's giant metallic, so it's still electrostatic because these are full-on charges, but we'll just put forces of attraction here because I've got less room. Between, and of course whenever you mention the word attraction, you've always got to state what it is between. So between, now this one is the positive metal ions. And the negative delocalized electrons. Okay, so that's that bit done. I just need to do a comparison now between each of these. So sodium bromide has a higher melting point that is higher than that of sodium and higher than that of sodium iodide. So sodium iodide then, so this is let's just do a comparison here. So strongest, now this is ionic, which means that the sodium iodide is probably going to be stronger than the metallic as well. So let's state strongest, and then we can do weakest over here when we compare these along here. So let's just make a statement here that ionic is stronger than metallic. So basically I've compared sodium bromide and sodium iodide against sodium, but now I need to talk about the difference between sodium bromide and sodium iodide, and this is where I need my periodic table. So sodium is in group 1. That's common to both, so the effect of the strength of the ionic bonds is nothing to do with sodium. It's got to be down to the bromide and the iodide. And if you look down group 7, bromide is higher up, which means it's going to be smaller with the same charge, which means it's going to have a stronger attraction to the positive sodium ion. Things to watch out for here: if you mention bromine or iodine, you'll lose these marks here. Okay, do not get confused between bromine, bromide, iodine, and iodide. So bromide, the easiest way to get around that is to actually put the ion like as that. So bromide is smaller than iodide, therefore attraction to the Na plus or the sodium ion is stronger. So that's probably going to hit all 6 of the marks. I'm just going to have a look through the mark scheme, and I know you'll be able to access the mark scheme. So stage 1 is all about talking about sodium. So sodium has metallic bonding. Yes, we've said that it's giant metallic, so we've got that. There's an attraction between the positive ion and the delocalized electrons. Yes, I've got that. And it is a giant structure, and I've got that as well. So that's 2 marks for stage 1. Stage 2 is about the ionic bonding in sodium bromide or iodide. Now, I've done the 2 together. There's an attraction between the positive and the negative ions, I've said that, and that it is a giant structure. So I've got all 2 in stage 2. So that's 4 marks there, or all 3. There's 3 criteria for 2 marks. Stage 3, ionic bonds are stronger than metallic bonds. I've got that. There's a stronger attraction between the ions in sodium bromide than sodium iodide. I've got that as well because the bromide is smaller. So that hits all 6 of those marks.